Alright, so at this point in our lives we are looking at three diagrams. This is the second part of a two-part video. So in this video we're going to look at the tree diagram as well as the odd numbers of that exercise I gave you for homework. Okay? Alright. So let's read on what they say about tree diagrams. And this is the example on page, let me just check here. This is on page 111. Yes? 113, sorry. Yes?
Are we doing the homework right now, so like is there a photo of like putting the homework in the group? Other people that's absent.
Yes, because of the people that's absent and you know the people that's isolating, the people that has better things to do than come to school. For all of them, this will benefit them. Okay. And for those of you who have missed some understanding of it, you have a chance to re-watch it and make sure you understand. Also at this point you can pause the video at any time and re-watch the question, or pause it and do the question, or rewind, whatever you need to do. Okay. You guys know how this stuff works. Okay, so we're looking at the tree diagram on page 133. We are told that it's a useful diagram if two actions are carried out one after the other. So we have two things happening, one after the other. Okay. So now we're looking at example 4, as we indicated it's on that page there. We're going to put this a bit up. In example 4, we are told there are 5 yellow balls and 4 red balls in a bag. So let's draw what we should be seeing. So it's 5. So 1, 2, 3, 4, 5 yellow balls and 4 red balls. Okay. In a bag. So how many balls are there in total? There are 9 balls in the bag. Not so. A ball is drawn from the bag and replaced. Okay, so say for argument's sake, I draw one ball out of the bag, I draw a red ball out. Then how many balls do I have left in the bag? 8. But before I do the next draw, I put that one ball back in the bag. And how many balls do I have now in the bag? 9. So the probability of you drawing a red ball in the first draw is the same and equally likely as drawing a red ball in a second draw. That's I read in the first question. Draw a red ball in the first draw is equally likely to drawing the red ball in the second draw, or drawing a yellow ball in your first draw is the same probability as drawing a yellow ball in the second draw. You guys understand that? No? However, if it was not replaced, would the probability be the same? No. So then the number of balls in the bag is different. But for you guys' purposes, we are looking at the ball is being replaced. Okay, just remember that. So replaced, and the second ball is drawn. Determine the probability of drawing. In the first case, a yellow ball. So remember they told us to draw a tree diagram. Okay? A tree diagram. So what we do is, this is what a tree diagram looks like. We start off here from this common point and we draw 2 branches. If there was 3 different colored balls, then I would have made how many branches? 3 branches. Okay? Right. So what are my outcomes? What are the options here? Can either be a yellow ball or it can be a red ball. Not so. So draw that in your books quickly. It can either be a yellow or a red. That's going to make this a bit less. What do you say? Neat? How much I know for you? Yellow and red. No? Right, so we have 2, no? The options or the outcomes can either be yellow or red. Now on the branches we write the probability. Okay? What is the probability of you drawing a yellow ball? What's the probability of drawing a yellow ball? 5 over 9. Not so? Now I want you to write down the probability of you drawing a red ball on that branch. Okay, just write it there quickly. I check my message. No? Important. Okay. So what's the probability of drawing a red ball? 4 over 9. Right. So when I draw a ball out of the bag, what's going to happen? I must replace it. Not so? But what do you, before we go into that, what do you notice about these two values? You notice are the same as what else do you notice? Here we go, well done. Together they give you 1. Right? 5 over 9 plus 4 over 9 is 9 over 9, which is 1. And what does 1 represent here? Everything. Yes, well done. 1 represents everything. Okay, you guys understand? So whenever you see a tree diagram, remember that, or keep that in mind, that the sum of the branches, the sum of that branch plus the sum of this branch, coming to one point there, will always be equal to 1. That's very, very important. We're going to use this concept all the way to grade 12. Okay? You will see now easy grade 12 work is. Grade 12 is laughing, yes. They didn't take note when they were grade 9, that is why. Yes, yes. No? It's okay, they get a second chance. Everybody gets a second chance. That's it. Right. But make it count this time, no? There we go. Right. So remember, this is what we call our first outcome. Okay, outcome 1 or event 1. Okay? So that is event 1 or draw 1 or whatever 1, the first event. Okay? So what happens now, once I draw that, what's going to happen to the ball? I'm going to put it back. And putting it back, we said is called what? Replace. To replace it. Okay? So we're replacing the ball. So if I draw a yellow ball on the first row, okay? Let me settle down. If we draw the yellow ball on the first row, then on the second account, what are my options? If you're putting the yellow ball back into the bag, how many balls do I have in the bag? Still 9. We have 5 yellow and 4 red. Can you see that, people? So it's still going to be yellow and red. Okay? If I draw a red ball on the first account, if I draw a red ball on the first account, and I replace that yellow ball, the red ball, sorry, I replace that red ball again, then what are my outcomes on my second draw? It'll still be yellow and red, or red. Can you see that? But what is my probability now of me drawing a yellow ball on the second draw? Remember, this is again in the bag. What's the probability of you drawing a yellow ball out of this bag? Sorry? 5 over 9. Okay? What is the chance of drawing a red ball out of this bag? 4 over 9. Right? If I draw a red ball out the first account, or the first event, or on the first draw, and I replace that ball back into the bag, what is the probability of you drawing a yellow ball? 5 over 9. And a red ball? 4 over 9. Again, people, what did we say? That adds up to 1. This adds up to?
1.
This adds up to?
1.
Always coming back to this point here. It will always add up to 1. So your branches, branching off from a particular point, will always be equal to 1. See any confusion? For those of you who have been here from the beginning, no confusion. Okay. So let's look at the outcomes. Okay. It's 4 over 9. Let's look at the outcomes. Okay. Let's put the yellow balls there. Okay. My outcomes, it could be. Okay. If they say list your outcomes, the meaning you must do the following. It can either be yellow or yellow. These are your options, yellow or yellow. Not so. What's the next option it could have been? Yellow or yellow and red. No? And because it's happening at the one after. Okay? Yellow and red. It's yellow and yellow, yellow and red. What is the other option it could have been? Red and yellow, yes. Or red and red. Okay. You all understand? Any confusion? What do we call that? What do we call this? Your outcomes. Okay, those are your outcomes. Okay, so you can, from that bag, you can draw a yellow and a yellow. One after the other. We can draw a yellow and a red, or a red and a yellow, or a red and a red. And this is what we call our tree diagram. Okay? If they tell you to list the outcomes and the probabilities, then we have to go a step further and say that would be the probability of yellow and yellow would be 5 over 9 times 5 over 9, which is 25 over 81. You guys understand? What if they ask you to work out the probability of yellow and red? Yellow and then red. 5 over 9 times 4 over 9. Can you see that? 5 over 9 times 4. What if it's red and yellow? 4 over 9 times 5 over 9. If it's red and red, 4 over 9 times 4 over 9. Easy. No? You would agree with that? You just tell me when I'm going too slow. No? I can just pick up the pace a bit. No? I know I'm moving slow here. But you tell the others why, no? You know, it's to do with. Right. Let's look at B. Sorry. Now we look at the first question. Okay, I think the calculator's in the way there. Let's just check. Nope, it's fine. So A. So A says, determine the probability of drawing 2 yellow balls. Okay, I think you can move this up a bit. What's the probability of drawing 2 yellow balls? So that is A. 2 yellow balls. So the probability is yellow and yellow. Not so. So what's the probability of drawing 2 yellow balls? 5 over 9 times 5 over 9, which is equal to
25 over 81.
You guys sound sharp, no? But we just did that sound now.
But still stuck in me.
Still stuck in you. Nice. Now I want you guys to work B out quickly, okay? And don't call the answer out, because I see some of you understand as well. One of each color. You write your answer in here, no? Then you wait for me. Alright. One of each color, don't discuss it. Joking, man, I'm not that crazy. Right, you said you know the answer? The answer to B is?
4 over 9 times 5 over 9.
Okay. Give it a chance. How are you doing? So how did you get 4 over 9 plus 5 over 9? Yes, 4 over 9 times 5. How did you get that? What is the question? one ball of each color. So you went 4 over 9 times 5 over 9, which is this one here, not so? But you say you got something different. What do you have?
So after 5 over 9 times 4 over 9.
5 over 9 times 4 over 9, which is that one. Somebody got something different? Both of you are correct to an extent. Because if we look at what they say, one ball of each color. That is one ball of each color, not so? And this is one ball of each color. So what must I do? You must work out that probability plus that probability. So I must take that two probabilities and add them together. You guys understand? The question didn't say one of each color, or it didn't say one yellow then one red. If it was one yellow then one red, then it would have been the first case, this one here. If it had said one red then one yellow, it would have only been that one there. Makes sense, people? But it says one of each color. So it didn't specify which one must come first. So I must account for both here. So in other words, the probability of yellow then red plus the probability of red then yellow, which will be yellow then red is going to be 5 over 9 times 4 over 9 plus 4 over 9 times 5 over 9. Can you see I'm following this branch here now? Okay, so work that out. Then on a calculator, 5 over 9 times 4 over 9 plus 4 over 9 times 5 over 9. What could I say 4 over 9 times 5 over 9 times 2? That's the probabilities of it. The same. Gives you 40 over 81. Okay. People, any confusion? Yes, Michael.
Just want to ask, why do you add y and
Why are we adding?
yes, so why do you add them?
Because the reason why we're adding is because the question says one ball of each. So the probability of you throwing a yellow then a red is this here. Okay? Or red then yellow then is that thing, which is this here. Because both satisfy what they asked for. That's why I have to put it together. I have to add it together to get both into account. Okay? So it's that one or. And remember, or you will always add. If it's and, you multiply. Okay? So we will add the probability of yellow and red to the probability of red. Okay? Anybody else? You all okay with this? Right. So what we're going to do is, we'll stop this video a bit, we'll pause it, and then we're going to do the examples. Oh, not the examples, but the homework. Yeah. We're going to answer them now. Right. So now we're looking at number 1. In number 1, we are told that the dice is thrown. You guys know what the dice, no? The thing was that you, yeah, we're not gambling. No? Determine the probability of. Remember, how do you calculate probability? It's number of favorable outcomes over number of possible outcomes. Okay. How many outcomes are here? 6. If they ask you to list the outcomes, what would it be? 1, 2, 3, 4, 5, or 6. That would be our outcomes. Okay. There are 6 outcomes. So determine the probability of throwing a 6. How many 6s are there? 1. So it's going to be 1 out of 6. B. Throwing a 4. 1 out of 6. Why? Because there's only one 4. C. Throw a prime number. That's an even number. What are the options? If it's even, it can be either 2, 4, 6. So how many favorable outcomes are there? 3. So it's going to be 3 out of 6, which is D. This is throwing a number greater than 4. What are your options there? 5 and 6. Why not 4? Said greater than. He didn't say greater and equal. If it was greater and equal, I would have included 4. So greater than 4 is 5 and 6, which is 2 out of 6, which is 1 out of 3. Any confusion here? Yes, Michael?
So we have to simplify it.
All the time. Always simplify. Okay? Otherwise, you don't want all your marks and then you just leave it. Okay? So let's go to the next question. Number 3. Okay, there's number 3. Answer those questions, please. Right, so in question 3 we are told a ball is drawn from a box filled with balls as in the diagram below. So we have reds, which is marked with R, so it's 1, 2, 3, 4, 5. 5 reds. There's 1, 2, 3 whites. 2 greens. 3 greens. There's 1, 2, 3. 3 greens. And 2 blues. So that's 6, 7, 8, 13. Is that correct? So count 13 in the back. Okay. So what is your number of possible outcomes? 30. Your favorable outcomes is the condition given. Okay, you guys understand? Right, let's go with the first question. Determine the probability of drawing in the first case. A white ball.
3 out of 30.
3 out of 30. B. A green or blue ball. So it's green. It's 3. Blue. 2. So that will give you the probability of blue plus the probability of green. Not so? Which is going to be the 3 over 13 plus 2 over 13, which is 5 over 13. You could have gone from this straight into that answer. No problem with that.
Just remember, there's a 4, it's a 5.
Plus, absolutely. Well done. You will become a teacher. Okay, we need teachers, no? You can become a teacher. Huh? We will see a ball which is not red. So how many balls are red? 5. How many balls are not red? 8. So in other words, the probability that the ball is not red is going to be 8 over 30. 8 over 30. Okay, any questions here, people? Any confusion? No. Right, let's do question 5. Stuff is easy, no?
Yeah.
I can't help that it's so easy. Okay, so in question 5, the ace, king and queen of diamonds. Ace, king and queen of diamonds are drawn from a pack of cards and not replaced. So let's just check here. So we've got the ace, king and queen of diamonds. So 3 cards are taken from the pack of playing cards and are not replaced. Determine the probability of drawing. So if these cards are taken out of the deck or out of the, what do you call it? Pack of playing cards. Then how many cards are left? 52 minus 3, which is 49 cards. Not so? Right. 8. The question says, determine the probability of drawing another ace. So how many aces are left in the pack? 3. 3 out of 49. Which remains 3 out of 49. Not so? B. Another diamond. How many diamonds are there in a diamond suit? 13. 3 is taken out of 13. We are left with 10. So it's going to be 10 out of. Did you all get that right? Who got a different answer there? How? Did you all get that? Simple, no? C. The ace of spades. 1 out of 49. Why 49 and not 52? Because these 3 cards are not replacing back into the pack. D. A card greater than 10. Now which cards are greater than 10? Jack, Queen, King. Ace, is ace greater than?
No, ace is number 1.
But remember, some people, what they do is, they pack, they count like this. It's 2. 2 is the lowest. 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King. Ace. Remember, we started off by calling this in front of 2. Not so? However, that could be behind the king as well. Yes? If you look at a royal flush, no? What they call it, a royal flush? Poker? You don't gamble, I also don't gamble. You're not a casino. Okay, but your royal flush would work like this. It's 10, Jack, Queen, King, Ace. I think that's a real flush, you are not mistaken. Who of you gamble? None of us, none of you. Okay. But you see that for the royal flush, you got, I think it's 10 Jack Queen. You have 3 cards and then so on. So it's from 10 Jack Queen. So the ace is considered as a card greater than 10.
But so when you play crazy ace,
You play crazy 8 is different.
yes, sir.
Okay, so you're calling it a 1. Okay, so I'll tell you what. Let's then call ace a number greater than 10. And in the reverse, on the other side, we'll then call it a number less than 10. We'll do it both calculations. Is that okay? So, sorry? Okay, the card greater than 10. So if you're going with, in the first case, the cards being greater than 10 being Jack, Queen, King, Ace. If these were the cards greater than 10, I'm going to work it out if we choose the cards a Jack, Queen, King, without the Ace being greater than 10. Is that okay? So if we call these four cards that are greater than 10, then what is the probability of a card being greater than 10? So how many Jacks are there in the pack? 4. Queens? 3. Remember we took a Queen out there. Kings? 3. Remember we took out 1 there. And Aces? 3. We took out 1 there. Not so? So in total that gives me 3, 6, 9, 12, 13 cards. Not so? So the probability will be 13 out of 49. You will agree with that? On the other hand, if we choose these cards to be cards greater than 10, then how many options do I have here? 4. Queens? 3. Kings? Which gives me 10. So it's 10 out of 49. You guys understand? Any confusion there? No. So we're just going to do question 7. before we break for break. Okay. Right. So for this question here, question 7, we are told that if a red and blue dice are thrown simultaneously. What does simultaneous mean? At the same time. You got two of the dice. Which games do you use two dice in? Two die, no? One dice, two die. Snakes and ladders, yes. Who else?
Monopoly.
Monopoly. Yes. Okay. Scrabble. Gambling again. People, so a red and a blue dice are thrown. Okay, so one being red and one being blue, or vice versa. Simultaneously, there are 36 combinations. Complete the grid to show the total of the two dice for every possible throw. Now determine the probability that we're throwing two dice simultaneously, and they give you what they're looking for. So if you complete the table, what goes here? Okay, we get 1, 1, so this is 2. Yes, you go?
3.
3. Yes. Then 4, 5, 7, 7, 7, 7, 8, 12, 6 and 6. No? So 3 and 2 and 2 is 4, 5, 6, 7, 8, 5, 6, 7, 4, 5, 6, 7, 8, 9. That's 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11. Okay, that's when you throw the two dice. Two dice makes a die. One dice, many die. So 5 plus 5. Can you see that? 5 plus 5 gives you 10. That's how I get that 10. No? For those of you who are confused. Then the question says in the first case. Now A. In A, the question says the total is 12. So before we go into that, what is your possible outcomes on this? And in this case, 36. There are 36 outcomes there. Possible outcomes. A probability of getting a 12. How many 12s are there? 1. 1 out of 36. Makes sense? So look at it again. The favorable outcome, they're looking for a 12. And there's only one 12 out of 36 options there. Let's look at B. The total is 9. So the total is 9. So how many options do I have there? It's 1, 2, 3, 4. There are 4 9s there. Which makes it 4 out of 36. Which is 1 over 9. 4 out of 36 is 1 over 9. Okay. Let's look at C. The total is less than 10. The total is less than 10. Would I consider the 10? No. So the total is less than 10. So it's going to be 4, 5, 6. Okay. There's not going to be a good way to count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 5, 6, 17, 18, 19, 30. That's 30. Or I could have counted it easily by just counting how many is 10 and more. Not so? How many is 10 or more? 1, 2, 3, 4, 5, 6. So how many is less than 10? 30. Makes sense, people? Okay. Take all the dots away. So the probability is simply going to be 30 out of 36, which is 5 out of 6. Let's look at D. In question D, says getting a double. So how many doubles are there? Can either be double 1, double 2, double 3, double 4, double 5, double 6. So how many options are those? 6 out of 36, which is 1 over 6. Okay? Let's take this out here. Whoops. Yes, ask.
How do you get 30?
30. For C. Remember what was the question? Less than 10. So I have to count all the numbers that are less than 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
So you can't put the number that's under 10.
Yes, the under 10. Let's look at E quickly before we leave. In question E it says, the total is more than 6. Do I include 6? No. The total is more than 6. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 19, 21. You guys understand? So is the probability simply going to be 21 out of 36? 3 goes into here 7 times, 3 goes into 36, 12 times. So it's 7 over 12. People, you guys understand? And the last question, before we leave, I know you guys want to leave, is if, in if, getting a double and the total is more than 10. A double, so remember, we highlighted the doubles, and it must be more than 10. The only options more than 10 is 12. So what would the probability then be? 1 over 36. Not 12 over 36. No, why? Because of the favorable outcomes. There's only one that fits what they're asking for. Okay? Over the number of possible outcomes, which is 36. Alright, so for homework, it's going to be the even numbers. People, enjoy the rest of your day. Good morning, class.